Okay, so let's go ahead and reverse course, and this time what we're going to be doing is curve fitting. So we have some secant and cosecant graphs, and we're going to basically try to find the graph that fits that. And like we did with the graphing, it turns out that a nice trick is to actually, let's go ahead and graph what the cosine would look like, and we can find our A, B, C's, and D's using that information. And then once we have the A, B, C's, and D's for cosine, we essentially have it for secant. So looking at this graph here, we can see we have some, that's a pi over 2, by the way. So we have a, looks like a vertical asymptote about pi over 4. And so again, where we have vertical asymptotes is where we are crossing, all right, an equilibrium. Oh, and by the way, this high point's 1 and that low point's -1. So our equilibrium looks like it is the x-axis. All right, so that basically tells us right away that c is equal to 0. Looking at this, and then we're at a high point, we're at 0, low point, we're at 0, high point, we're at 0, low point, and just keep going. And we can even come back here, low point, 0, high point, low point, 0. So here in red is basically a graph, right, of our cosine of x function. So what do we see from that? Well, one thing that I notice is that we usually expect cosine to be starting at a high point, right, and this high point has been shifted over pi over 2. So it looks like our D, right, is going to be pi over 2. Our A is going to be 1 because the equilibrium is the y equals 0, and this graph is going above 1 and below 1, so the amplitude is 1. And then last but not least, the B, as I move from, this is pi over 2, and this is 3 pi over 2. So when I look at how far it took me to go through one complete cycle of cosine, right, our period is 3 pi over 2 minus pi over 2, which basically gives us 2 pi over 2, which is pi. So we're almost done. So that means that pi is equal to 2 pi over b. Do a quick cross multiplication. We get b times pi equals 2 pi. Divide both sides by pi, and we get that b is equal to 2. So b is 2, a is 1, d is pi over 2, and c is 0. So basically, that's for the cosine. It's going to be the same thing for the secant. So our function that fits this is the secant of 2 parentheses x minus pi over 2, right? And that's basically it, right? Now, of course, you might see that in the textbook as 2x minus pi as well, if you distribute that 2. All right, so that is how we're going to play this game. Again, the next graph, I apologize for the lightness and color. If I move my camera down, we can maybe see those numbers just a little bit better. But again, we have some asymptotes, and it looks like an asymptote's occurring at 2 pi, right? Which means another one's occurring at 0, and another one's occurring at, looks like 4 pi. All right, so when we read those graphs, so it looks like we have asymptotes there. And by the way, we're fitting a sine graph, and then equilibrium-wise, this is 3, and this is -1. So the halfway point between there is y equals 1. All right, so we kind of know what c is automatically. And so graphing a sine graph from this, right, we're going to be crossing the equilibrium at those locations, and we're going to be at a high point, we're going to be at a low point, we're going to cross and be at a high point. All right, and then just keep repeating that. So what I have in red, there's the graph of our sine x function in red. So what do we have? Well, first of all, notice that the action is doing what it's supposed to be doing. Sine is usually going through its equilibrium at the start. So this is neither shifting left or right. So that tells me that D is equal to 0. My equilibrium has been shifted up to 1, so that tells me C is equal to 1. My wave, we're going from 1 to 3, or from 1 to -1, so my amplitude, A, is 2. So the only thing left is B, and that's period. And it looks like we're going from one cycle of sine all the way to from 0 to 4 pi. So it looks from the graph like my period is 4 pi. So that means that 4 pi is equal to pi over b. And then we cross multiply, we get 4 pi b equals pi. Divide both sides by 4 pi, cancel some stuff out, and it looks like b is equal to 1/4. So I have everything I need to know. So we have, for this graph, we have f of x is 2 cosecant of 1 over 4, I guess x minus 0, and then plus 1. And let me rewrite that. So that's 2 cosecant of 1/4 x and plus 1. And so there would be the cosecant graph that fits that data. And so again, we're using that same trick. We're trying to take advantage of what the sine or the cosine graph looks like to kind of help me get the A, B, C's, and D's. And we're basically analyzing the function using what we learned in 4.1 and 4.2. So there's the trick. So that should wrap up our secant and cosecant graphs, what their basic shapes look like, how to transform them, how to curve fit for them. If you need help, please ask for it. Come see me for office hours. Jump online and ask questions on Canvas. Rewatch a couple of videos. I've got myself as well as some other people talking to you on how to do all this crazy stuff. All right, so live and learn, and I will talk to you guys later. We're going to be moving into a new section soon. New videos coming up.